So there's a game that Americans like myself know as tic-tac-toe. I think it's also known around here more as noughts and crosses. There's also X's and O's. But just in case you don't know what that is, let's make sure we're all on the same page. So it's this game, someone clicks a spot, someone else can mark somewhere else, and you just keep going like this. And once someone gets 3 marks in a row, they win, right? So this is the game. And so what we want to do is we just want to design an API for that game. That's it. So let's define this API. Well, we know that there are some positions. We're going to enumerate them all the way from top left to bottom right. We also are going to have some marks. So we can have X's or O's. Those are the only 2 different marks. And then we are going to have this board state. And we can give it a position, and it'll give us back what mark is at that position. Option might not have a mark there yet. And we can also set positions on this board by giving a position and a mark to use, and it'll mark that. But we're at functional Scala, so you can probably see what's wrong with this API. It's because we're using unit, right? That's incorrect. That would be a no-op in functional programming. So we're going to change it. So now it's going to return a whole new board, and the board is going to have that new state set. So let's see how we use the API. So let's say we have a board. We actually don't care how it's constructed, but let's just imagine that we have a board. And we're going to go ahead and set some positions on this board, the top left to X, the center to O. And then we can query the board, like let's get the top left out. It's going to be option mark. We can see that the top left is going to be X in this case. And so we're going to release this API to the world. So imagine that someone is running this tournament with our API, and the final match is being streamed to the world, and we're lucky enough to watch this epic showdown, play out. So it begins, all right? So player X starts out, with an X in the top left. It's an all right move. Player O responds poorly. If you know anything about strategy, you know that this is not a good idea to put your O right here. Then player X is inching closer to that 3 in a row. But player O isn't too terrible at the game. They know they should block that. So they put the O in the top. And then player X is setting up the inevitable win here. So we can tell that, well, O has a predicament, right? If they go right here in the middle, well, then X is just going to complete a diagonal 3 in a row. Likewise, if O tries to block the diagonal, then X is going to have a vertical 3 in a row, and they're going to win. And so, player O thinks about this for a while, and they just don't know what to do. But then they think of something, and they decide to replace the X in the bottom left with their own O. And so they've saved the game, right? They have figured out a way to extend this game longer. But if you know the rules of tic-tac-toe or noughts and crosses or X's and O's, this is illegal. You can't do that. You can't just take someone's mark and just put your own right there. And so we have a question. Who's at fault for this illegal play? So one of my favorite things to do when I encounter a bug in programming is to blame someone else, I don't like to be accountable for my own bugs. I know accountability is a good quality for programmers to have, but it just feels so much better when someone else is accountable for the problem that I have. So my question is, who's at fault for this illegal play? So it could be the player who made the illegal play. They should know they can't just replace someone's mark. It could be the tournament organizer who used our API, or it might be the developer who designed the API. And I would argue that the person at fault is the developer who designed the API. So sometimes we feel like a person might be misusing our API, and let's see how that is the case here. So again, we had a board. And in this tournament, we just had a board in some state, and then we saw that the bottom left at some point in the game got set to X. Well, is that safe? We don't know the state of the board. But we do know that when someone set the bottom left to O, that was definitely an illegal play. This compiles, though. So we're setting bottom left, and then we're setting bottom left again, and we don't get a compile error. That just seems to work. And then it kind of gets a little more hairy when we think about it more. If we keep going, well, what if that new board, we're going to get the bottom left from that new board? Like, what does that return? If you look at this code, you might wonder, well, X was the first thing that was set, so maybe it returns X. But also, we see the O was set next, so maybe it returns the next thing that was set. Or maybe it crashed right here because it saw that, we had already set X. There's all these questions that we shouldn't have to ask ourselves, but because our API isn't very robust, we do end up having to ask ourselves as the API user. And it gets confusing. It seems like there's multiple all right answers. But it's kind of sad. And I guess, and I will say, whenever we try to say that it was a user who misused our API, I think that should trigger something in our brains to think, oh, maybe it's the API that is problematic and not the users who keep misusing this API. So what is the primary goal of an API? I think the primary goal is to give the programmer an easy-to-use interface, right? That's the goal. It should be hard to misuse, but not hard to use. I think sometimes we take it too far, so it's so hard to misuse that it's also hard to use, and so no one uses it, right? So we want to make it easy to use and hard to misuse, but not too hard to use. And what I kind of point out, something I want to touch on is that data encapsulated APIs can be error prone. So when you encapsulate state behind an API, it makes it invisible to the type system. By consequence, the state is often invisible to the user. Hence, API methods that only work properly when internal state meets certain conditions creates pitfalls for the user, because they can't call that method in certain states. So someday, some user is going to call that method when they should. So the question is, can we design safer APIs? So ideally, APIs should only allow valid operations. And if the validity of an operation depends on state, then the API must ensure that state is met. I think we can agree that that would be a great property. I think the question, though, is how do we do that? And what I think we can do more in programming is have a more transparent API. So let's take this board, this tic-tac-toe or noughts and crosses game, and let's make things more transparent to the API user. So we have a board, and we're going to refer to this self-reference later, so we can just ignore that for now. But we are going to go ahead and expose all of the marks on the board to the user. So we have the top left all the way up to the bottom right. They're all option marks. They might have a mark there, they might not. Now when we have that, now we need to change up our get method. And so we used to pass in a position, and then we got back an option mark out. But let's return instead something that's a get position.type. What is that, though? So a type of get, it is an option mark, but we can be more specific than that. So we can take that position P and we can match on it. So in the case of top left, if they give us a top left position, well, we're going to go ahead and reference that top left variable and return that type. We can specify that that is the type that they're going to get back. Likewise, for all the different positions they pass in, we can specifically tell them which type they're going to get out. And we also want set to be a little more transparent. So when we give a position and a mark, it used to return just the whole new board that we got back, but now we're going to return some set type. What is that, though? Well, it takes a position P and a mark M. It is a subtype of board, but we can be more specific. So we can take that P position and we can match on it. And so in the case of top left, we can say we're going to return a board, but we can refine that type and say in that board, the top left is now going to be a sum of M, the sum of that mark. So it's not just an option, it's a sum of that exact mark. And so we now know that we have a mark there, and then all of the other positions we just carry through from our current board state, and those are going to be the same types that they are in our current board. And then that's just for top left, so let's go ahead and do it for the rest. There we go, ellipses, we did it. And that, I mean, this will be long. You can make this nicer, with type aliases, but I want to be very explicit to show that this is what is happening. So how do we actually use this new transparent API? So let's say we're going to create a blank board. We can just say new board, and we can override all of the values to a specific type. We can refine their return value to be none.type. So we can kind of encode that it will be none, that there won't be any marks on the board. That means we can go ahead and get the center from the blank board, and we actually know that it's none.type, at compile time. We don't know that it's just an option mark. We know that specifically it is empty. And similarly, when you set the center to X on this board, if we get the center of that new board, we don't just know it's an option mark, but we know it's a sum of X. So we know the exact type of the board. So we're being transparent in what these methods are doing to the board, how they're affecting it. But we haven't really solved this pitfall that we set out to solve. So when we have a board, we can still, set the bottom left. We don't know if that's, if that's full or not. And then we can also overwrite what we just set. Now we know that's definitely illegal, but it still compiles. So everything still compiles when we don't want it to. And so how do we go ahead and prevent this overwrite pitfall? So this is what it looks like right now when we set a position. But what we want to do is, what we can do is we can add a guarantee parameter. It's another parameter list that is unoccupied at that position.type. This guarantee type is from this library right here. And unoccupied, or now it's just like an empty trait. So right now, basically, this just reads nicely, but maybe we don't know how it works. So we need to have a guarantee that it's unoccupied at that position type. But how do we guarantee, right? So up here is we have the position, or our set method definition. And well, one way we can get a guarantee is you just gotta trust me, right? So if you have a board, and let's say that we do know something about the board, so we refined it so that the center is none. Doesn't matter how we got here, but somehow we know that. So we can call board.set the center to X, and we are going to use some guarantee.trust. Just believe me, this will work out. So we're telling the type system we know that it'll work. So we're being trustworthy here. But the problem is we can also be untrustworthy by setting the center to O immediately after that. And this will compile. So, I mean, we can get a guarantee through trust, but we might be lying. So the problem is that I don't trust you, though. That's the problem. So trust isn't good enough. So let's say we just have a board and a position. This time we know nothing about them. We just know that we have a board and a position. And what we can do is we can test at runtime board.unoccupied at position type, and we're going to match on it. How this works, we'll go into it a little bit at the end of the slide, but just know that right now it's going to test at runtime if the board is unoccupied at that position. And what that returns is an either. So now we're going to handle the right case. So in the case that it's right, we do get that guarantee that the board is unoccupied at that position. So in that case, we can go ahead and call board.setPosition to x. That'll compile. But if we try to set the board to center, that won't compile because our guarantee is only for this position. It's not for center. So that won't work. Or if we just have another board and we try to set that position to x, that doesn't compile either because our guarantee is on the board and not other board. So that doesn't work. In the case of left, we'll actually get a guarantee back, but it's going to be the opposite of what we want. So it's guaranteed that it's not unoccupied. Maybe we make a type alias called like occupied at that position. In that case, if we still try to set it, well, it's not going to compile because we don't have the guarantee and scope that we need to have. And so, but how does all this work? Well, there's a compute type class that you can implement. And so what we do right here is say, if we have some type P, and if that P computes to a position, then we can get a compute of type unoccupied of P, and that will return a Boolean. And the way that works is, well, we just call compute on P, and up here, you can see that that returns a position. So we're going to get the position on that board, and then we're going to see if it's empty. And then we create a compute out of that, and that is telling us, is that spot empty on the board? And when we implement this type class, it makes it so we can use this test.runtime with this unoccupied, test this constraint. So you can also do some static verification. We won't go into this how this works, but it's similar. Similarly, you implement a type class called inlineable. And that'll let you do stuff like if you have a board, the center and top left are both empty, you can go ahead and call board.setTheCenter to x, and that compiles. And if you set the center of O on that the return of that board, that's going to be occupied, so that's not going to work. Now, if you set the top left, that will work because it's still unoccupied. But if you set the bottom right, then we don't actually know if that's unoccupied or not. So we are going to, it doesn't compile because it's going to be safe. Try to keep you safe. It might be an accident. So double marking a position is now prohibited, right? So attempting to mark an already marked position triggers a compile time error. And attempting to mark a possibly already marked position also triggers a compile error. But we can also discover and remember an already marked position. And that can happen at runtime when we don't have insufficient information at compile time, like in the case of, two players are playing online. And so we also know this isn't quite good enough, though, because we run another tournament and we find out someone has found the optimal strategy to winning, and it's moving really fast. So they go ahead and they just put all their X's down real fast, and they win. O never has a chance to go. And so when we see this bug in a tournament, we immediately think, well, who's at fault? And if we really think hard and we're the developers, we realize it's our fault as an API developer. We didn't prevent this from happening. It's not the cheater who moved too fast. Maybe they don't know. Their cat jumped on the keyboard, clicked X a lot of times. So let's patch this up. We want to fix this. And so now the board is going to contain a little bit more state. It's going to expose that there was a previous turn value. Maybe no one has actually moved yet, so it's going to be an option mark. And then our set method, well, we just need to add another guarantee. So we have that guarantee that wherever they're trying to mark is unoccupied, but we also need a guarantee that it is the person's turn of that mark who is moving. And we won't implement it, but we follow a similar approach that we did with unoccupied. And now our API is nice and impossible to use unless we lie with the guarantee trust stuff. But API users, this will it'll alert them when they try to call these methods that they need to check beforehand that it is the person's turn and the position is empty. And I think this kind of is, in my experience, been the missing piece when I'm trying to do domain-driven design. So whenever I'm trying to model something, a domain, I think guarantees they fill the void that's left by the type system to fully specify domains. And it works by exposing state to the type system, and that it can be verified both dynamically and statically. Those guarantees can be figured out, beforehand in source code. If you don't have enough information at compile time, you can wait till runtime and you can figure it out then. I think the runtime is far more useful and occurs far more in practice. But yeah, and we harness singleton types and structural refinement in Scala, and that means that our APIs don't have to be overwhelmed with type parameters. So another way we could model, a board is to have like 9 type parameters for each of the positions. But that, I don't know about you, but that gets kind of overwhelming when I see so many type parameters. And I think when you refine something structurally, you're only looking at the parts that you're interested in, and not looking at 9 type parameters every single time, even if you're only interested in 1 or 2. And so I like that about this approach. And I think user-defined custom guarantees are essential. So sometimes we like to have automatic verification, but it only works for things like arithmetic or string operations. But for someone who's writing tic-tac-toe, they're going to have these operations that they need verified that aren't going to meet, all those like SMT solver type things. They're going to have very unique things that they need to turn into guarantees that can be computed with their own code. And I think, in summary, guarantees, they protect your API, guarantee their users, that protects the users, and it protects yourself from all these bug reports because you don't have to worry about them because it would be caught at compile time. So I just want to say thanks to everyone. This is a repository that you can check out how some code for this, and but it doesn't have release. It hasn't been released, or documentation is lacking. But that's just temporary. Don't worry about it. Oh, we'll figure it out. Yeah, thank you, and that's all I got.